You can see me. Well, not see me. Now you can see me. See me, hear me. Hopefully, everybody. I'm hoping so. Hello, everyone. Let me know if I'm 5x5 or 5x9. This has been a very interesting last couple days. Let me just start. If everyone can see me, give me thumbs up. If everybody can hear me and see me, it looks like my mic is good and all should be good. 5x5, excellent. Hey guys. Hey Jerry. Oh, thanks, Jerry. 5x9, excellent. Speaking of, let me grab my phone. There are a few people here, my VIPs and moderators have my cell phone number so they can get a hold of me if something goes wrong. I do have it on. So excellent. Thanks so much for all this, guys. Let me get over immediately and without further delay and say, don't worry, this is not a Carrington event. Okay, we're not going to die. let me just get that out of the way. So anybody who is sweating, worried that, cats and dogs are going to rain from the skies, we're fine. We're really fine. It's this is what is making this such an interesting set of events is because the sun is basically going once again. We've got a bad actor that is very upset, and he's just upset. it just won't stop firing storms and launching flares, and it looks like it's getting worse. In the sense, I don't want to say worse because that's everybody goes no. We're not done yet. Let me just put it that way. And I'll show you, I'll go through the details of that. And that is not just fun, but it's also complicated and kind of a headache for a lot of us because as space weather forecasters, it's much easier to forecast simple events. Forecasting rapid fire things is very, very difficult. Not to mention rapid fire things when we have something as complicated as what I will show you here. Actually, I probably won't start with this now that I think about it. But as you can see very quickly, there is this really kind of crescent-shaped finger-like coronal hole. And this is not something we like to see when we're trying to do a simple forecast. The fact that the bad actor, as you can kind of tell from here, is like sitting in the middle of this thing or just really close to it, doesn't help either. And I'll go into that in a little bit. But first, let me go ahead and jump into it. I'll just jump into the simpler stuff. I probably should have started with that. Let me show you something simple. Okay, so hello everyone. Hopefully everybody sees me. I promise to go back and read through all of your comments. If you are a Patreon member, please put comments. If you don't get a hold of me, put comments in the Patreon feed. I will check them and answer your questions. Hi, Lisa. By the way, I do owe you an email and a phone call. I know that. So just wanted to say that. That's Lisa Pattinson. Okay, so we have a bad actor on the sun right now. This is region 3078, and I will stand away from it so that you may see this region. This guy, as you can tell, is just lighting up like a Christmas tree over the last couple days. And yes, this is SDO. These are AIA images. This is, if anyone's interested, the pink sun is 211 angstroms. The reason why I'm using that is because not only can you see all the puffs very easily that are the big solar storms that are being launched, but you can also see this really nasty looking coronal hole that just is not, it's a very common thing when we go into the ascending phase of the solar cycle. We get these really long finger-like coronal holes that are what we call trans-equatorial because they go across the equator of the sun. Yes, they are completely normal. No, they're not really holes. The sun isn't tearing apart. It's just cold. This area is just not emitting light in this particular wavelength. This is where fast solar wind comes. And for those of you who are familiar with it, the thing that fast solar wind does is that it has a tendency to deflect solar storms when they're launched. So we have to worry about the stream of fast solar wind that's coming from this very odd-shaped coronal hole, pushing these storms in one direction or another. As they launch from the sun, remember, launching from the sun is just the first step. It's like backing out of your driveway, okay? Now you've got to drive from New York all the way to Los Angeles, and all we get to see is how fast were you backing out of your driveway as a vehicle. So this was what makes space weather very challenging, is that we have no idea the kind of traffic that these solar storms are going to encounter on their way to Earth, okay? So yes, we have a G3 level warning, and the reason why we have a G3 level warning is because, as you can see, there's lots of puffs. That means lots of solar storms that are being launched. However, Some of these solar storms are going to be pushed south, a bit south of us. Not sure how many are actually going to be pushed north and into the Earth. So it makes it a bit complicated because the fast solar wind here, as you can see, is a bit northward of where these solar storms are being launched. In fact, one of my colleagues, Halo CME, which is Nariaki Nita, who is an AIA team member at Lockheed, he mentioned that even as this region is erupting, a lot of the eruptions are being stalled. They're being stopped right at this coronal hole. So you're seeing lots of blast waves, lots of things going south because it's unimpeded, but going north, it stops. Even the coronal waves stop. So it's kind of like it's trying to jump a chasm here. And when that happens, that means all of this stuff above that coronal hole is unperturbed, right? So this stuff doesn't necessarily launch. That's why we're not seeing a lot of big halo images in the coronagraphs. If you guys know what I'm talking about by a halo, we'll talk about those in a minute. Okay, so this particular actor, even though it is an X-flare player and it has launched lots of M flares right now, as a matter of fact, if I recall, it's launching or just has launched another one. Look, yet another one right here. Just now, we are coming down from yet another one. So if you are an amateur radio operator and you've noticed that you've been having some issues on the bands just now, this is almost an M2. This is a 1.8.6. I'm sorry, you probably can't see that number, but this is an M1 or 1.86, and it's eruptive. So we may have yet another solar storm launch. You can see by how this big long tail, see this big long tail? That the fact that it doesn't go down super fast, right? You see it goes sharp up. Gosh, get these things out of the way. It goes sharp up and then kind of goes, and it just kind of bends like a knee, kind of bends over. That is likely because there's another solar storm being launched. These are gradual flares, and that typically means a solar storm is being launched. So might we have yet another Earth-directed solar storm on top of the barrage that we've already had? Yes. Okay. So this is for all of you who are wanting hard facts. I can give you hard facts, but I can't give you anything other than a moving target in terms of a story to tell, because the story is that this region is going to continue to and rapid fire out these solar storms and solar flares easily over, I would say, until it disappears off the Earth-facing disk, which won't be, where is it now? Let's see, stop it. Which won't be for another 5 days, at least. Okay, maybe 6. Because it will probably be angry all the way through here and maybe even fire some parting shots in about a little bit less than a week as it leaves. So we will start really worrying about solar radiation storms, okay, because we're coming to the west limb of the sun. That will happen, so expect NOAA to start ramping up the risk for radiation storms. Right now, we only have about a 10% chance of radiation storms. These are different than solar flares. Radiation storms and radio blackouts are different. Radiation storms are particle storms, okay? So remember, with space weather, you often get lots of different phenomena happening together. So we have solar flares, solar storms, which are the CMEs that are going to cause the aurora, and then you're going to get radiation storms potentially on top of that. A lot to take in, I know. Okay, so let me show you a little bit more how fun this guy is. It's lots of eye candy. That's one of the nice things about are ramping up to solar maximum. I'm zooming in just a little bit so you can really see this guy. Look at all this material that it keeps jumping, throwing off, right? Lots of good stuff. Believe it or not, this region is not the only region that you notice that back on the 14th was really when it started to wake up. And this region is not the only one that has contributed to the solar storms over the past couple days. I'll show you the other regions in just a second, but it is now the one that we are watching for the big solar flares because it is an X-flare player. Okay, and you can see, notice that as time has gone on, as of today, it's really getting itchy, right? This thing is getting very angry. But when it started out, see, it just barely started. Really wasn't doing all that much. Okay, notice there's a couple other regions up here. Okay. All right, so let me just talk about those for a little bit. So we really have 3 regions that we've been paying very close attention to, and 3 that have been causing big solar storms or in the vicinity of them. The first one was back on the 14th. That was from this region here, which I think is region 3076. Someone correct me if I'm wrong. This region here back on the 14th launched a solar storm. You could see that was really nice, right? That was actually a partial halo that I'll show you in the coronagraphs. That one is definitely Earth directed. Don't worry, we'll get to the models in a second. Then after that, on the 15th, I believe, and we'll have to wait till the movie resets, but on the 15th, you will see a filament eruption that occurs. Come on, reset for us. Did it reset? I think it did. Okay, so there's the 14th. Now watch down here. You'll see a beautiful eruption over here, somewhere in here. Come on. There it goes. Wait, is that it? No, wait. Oh, where are you? Did it play so fast I missed it? Yeah, there it is. Boom. Ah, there it is. Okay, that was what I wanted to show you. That one happened on the 15th. Let me rock it back and forth so you can see. Boom, boom. You see that? So that was a solar storm eruption that that is really a filament. It wasn't even associated with really a region. Okay, it was a little bit further south. This one is going to pretty much go past us on both south and west of us, and then this one picks up. Okay, so then let me zoom out so you get a much better flavor for the whole sun. And this, for those of you who are interested, this is 304 angstroms. This is, are you playing? No, you're not playing. Play. This is the wavelength we use when we want to see the material that's being ejected, right? And how oftentimes it's really where you see a lot of the eye candy. So you don't necessarily see the puffs of stuff and see the extent of the solar storm, but you do see how massive some of the ejections are. And as we move up to solar maximum, we are going to see a lot more of this. So again, do not be concerned, okay? This behavior is perfectly normal, okay? We go through it every 11 years, and nothing we are seeing here is out of the ordinary, all right? And none of these solar storms, to be totally honest, are really, you know, anything that I would consider a nail biter, okay? If we had any of these solar storms happening by themselves, NOAA would probably yawn. Give us a G1, maybe a G2 at most, but you know, and only if they were direct hits. And that's the thing here, is that none of these really are well positioned to be direct hits at Earth. They're not really well in the Earth strike zone, which is this region for solar storms. The Earth strike zone is about in here. Think of a concentric circle that's kind of like, you know, about half, think of half of the sun, right? A smaller, again, size. For solar storms, that's not for fast solar wind, but that's the Earth strike zone for solar storms. And so as you can see, these regions really are either on the hairy edge of that inner circle, right, the Earth strike zone, or they might even be pretty close to outside it. So taken by themselves, none of these solar storms would really raise a finger. You know, we wouldn't really worry that much about them. But it's just that there's so many of them. Bang, 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 bang. And when that happens, they have a tendency to kind of sweep the field, clear. Think of big tanks on the freeway sweeping away the slow traffic. And so they clear the way for one another. And when the slower ones are launched first and the faster ones catch up to them, they can be even more impactful. This is mistakenly being called CME cannibalism. Poor Nat Gopalswamy rues the day he ever created that phrase. Cannibalism is not really true. They don't really eat one another. They can't, because these are magnetic structures. All they can do is plow into each other like bumper cars and slam into the back of one another and magnify each other. Okay, so what you see in the models, which I will show here shortly, those things, that doesn't really happen in real life. It's just that the models that actually show and depict realistically what happens, those don't run faster than real time. Okay, so before I jump into any questions about that, before I jump into the actual solar storms and I'm actually going to talk about the sunspot itself and show you the development of that sunspot first, before I jump into the actual solar storm modeling. And hopefully any of this makes sense to everybody. Hopefully. Okay, I see yes, perfectly good. Thank you for everything you do. They're very welcome. So will these solar storms produce aurora? Yes, yes. And the neat thing about these solar storms is that in this case, and I will show my 5-day outlooks here shortly, the neat thing about these solar storms is that we will have an extended amount of storming. And you'll see that very, 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 very shortly here. Okay, let's see. So what I will do is very quickly, let me show you the growth of this region over just the last couple days. You can't see that date, so I'm going to pull it down. So as we see it growing here. You can actually see this is region 3078. And really, it doesn't look all that impressive from this position here. It doesn't look like it's growing that fast. It's not the biggest sunspot we've ever seen. But what we do see is that it is definitely growing, right? It's getting more, and more colors. Do you see all the complicated colors? You see red, the reds out here, the blues on the outside. Well, if I pause it, or actually if I go, let me stop this and I'm going to go to Space Weather Live. They're a really good place to look for data. So this is going to be a little bit dizzying, I think. I'll show first the sunspot. You can see visibly how the sunspot has grown. There's a beginning, second day, on the 12th, the 13th, 14th, 15th, and 16th. It's probably a little too fast, but it gives you an idea of how quickly the sunspot has been growing. And so it's it continues to grow. And that is part of the issue. And now let me see if I can make this one work. Are you going to show me? Why aren't you working? This time, stop. There we go. Okay. So now let's do this side. So again, it's kind of fast moving, but start there from the 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, or 16th rather, sorry. I'm looking at your delay from me, so I shouldn't be looking here. I should be looking at my screen. But as you watch the sunspot grow, what I will do is I'll stop it when we get to, see if I can, well, you know what, I'll do it this way. Let me go to, I know this is a little bit dizzying, guys. There we go. All right. So hopefully what you can see here, this is the sunspot today. This is something we hadn't seen yesterday. See these little red spots in the sea of green and blue? You don't like it when red touches blue, okay, or when red is in green. These are what we call delta spots. So what's happening is that you're getting what we call flux emergence. The magnetic field of this sunspot, you're getting the opposite polarity coming up through something that's pointed the opposite direction. Anytime you get magnetic fields that are mixing, that have got one polarity, like let's say up, and the other polarity down, really close to one another, that's a high risk for, it's very unstable. It's a high risk for big flares. So this is why we have an X flare threat right now. No, I think right now is sitting at about 10%. According to this, I wouldn't be surprised if they upped it to maybe 15 or 20% for an X-class flare, because I do think there's a good chance we'll get one. But right now, we're still seeing M-class flares. And as long as we keep seeing M-class flares, we might not get an X-class flare. If the spot quiets down for a while, but we still see these delta spots, it could let off a large one. Kind of like the way earthquakes are, where if you don't release the pressure, consistently, then it can build up to give you a much larger quake than you would otherwise. So it's kind of a similar thing with these big flares. So radio amateurs definitely realize that you're hearing on the bands, with the noise that's on the bands, you're hearing all of it from mainly this region. There are a couple other regions that do have some big flare capability, but they're nothing like this one. This is the only one that's the X flare player. Okay, so expect that over the next day or two, and easily, if it doesn't resolve and the delta spots go down, we could be seeing an X flare player all the way across, for the next week, all the way across the Earth-facing disk. Okay, all right. So I'm debating whether I should show you the complicated solar storm models, or if I should just jump into my 5-day outlooks for those of you who'd like to get in and out. I think I'll show you the 5-day outlooks right now so that I don't spend too much time here. This is, hold on, I've just had somebody. This is updated for today. Okay. Yeah, I'm getting message. Oh, more solar flares. Are we getting another one? Hold on. Are we getting more solar flares, guys, right now? Because I'm sure getting a lot of notification. No, it doesn't look like it. That's how slow the notifications are. They're even slower than me. Not only is the solar flare over, I'm just now getting the notifications on my phone. Okay, let me go back to the 5-day outlook. So for those of you who are itching to know what the Aurora forecast is, it's a good one. And what I'll do is I will go over in detail why this is like this is. This I have now adjusted to include today's Space Weather Prediction Center forecast. They released it literally at 3 o'clock my time, which was like half an hour ago. So I'm scrambling because that's exactly when I was supposed to be on live with you. I was scrambling, updating this chart for you that had to have the latest NOAA figures on it. Okay. So yeah, when was the last time we saw a chart that looked like this, right? It's been a while. Now you can easily see, just with all the red on there, why NOAA is issuing a G3 level storm. But I'll have to go into the details of this a little bit, okay? NOAA is expecting major storm levels at high latitudes, there's no doubt. I mean, that's easily going to last, I would say, in through Saturday. And they're predicting a 90% chance of a major storm at high latitudes. So for those of you who are at high latitudes and the sun, the summer sun is waning, luckily the moon is also waning, so we won't have to deal with a super bright moon like we had this last storm. So this should be a really good chance for you at high latitudes. However, for those of you, who are able to see aurora, don't be surprised if you look at the north horizon and you're like, well, where's the aurora? You're looking up, where's the aurora? Turn around and look south of you. Okay, because the aurora literally may go south of you because it's actually going to drop down to mid latitudes pretty well. Now, at mid latitudes, NOAA is saying about this is where they're getting their G3 level. They're believing a G3 level will be somewhere on the 18th. I think there's probably a chance that we could have a G3 level on the 19th. I'm still hoping that we're going to get a G2 out of this. And I'll go into the reasons why shortly. But this to me is maybe a little bit of an overblown. I would say this is not a conservative forecast at all. Okay. Would I say this is an optimistic forecast? Yeah, I think this is optimistic. All right. But the big day, I think, will be the 18th, and we'll talk about why here just in a minute. NOAA's giving us about a 50% chance of major storm conditions at mid latitudes. So on the 18th. So this does mean we could see aurora as far south, easily as far south as Iowa, easily as far south as Peoria, Illinois, Colorado, yes, way past Seattle, yes, possibly down, almost. If you all remember the storm that we had back in November of last year, this one might be close. Okay, last year we had a storm that should have registered a G4 level. It did not make it there only because it didn't last long enough at the peak levels. But man, we had aurora clear down to Joshua Tree. Okay, could this? What is exciting to me about this for aurora people is that it's so long. We have so many storms hitting back to back to back to back to back that we could have sustained aurora. Okay, assuming all of the storms hit, and we'll talk about why I'm a little bit nervous that not all the storms are going to hit us. However, if they do, 18th is a really good time. Might even get storming in through the 19th. Okay, and calming down. Obviously, at high latitudes, you're going to have lots of different chances. Your big fight is going to be with the sun if you're in the northern hemisphere. In the southern hemisphere, oh my goodness, everybody in Victoria, Australia. And even possibly Perth. Okay, so you guys in Perth, dark skies, Australia, you could definitely be seeing it. And that means Tassie and New Zealand, of course. Hope your skies are clear. Everybody check your weather forecasts because this could be a good one. All right. Okay, now, I'm trying to see. What is this, Andrew? I'm sorry, I got sidetracked. Many other ridiculously wonderful women I can't listen to, but your skill and style and ability rival your wonder as a physical being. Oh, thank you. Oh my gosh, I thought it was a complaint. I'm like, oh no, what'd I do wrong? Thank you, Andrew. That was very kind of you. Yes, hooray for Seattle. No, absolutely. We should definitely get some aurora that far south. We need auroras in Vegas. Yeah, long as it doesn't stay in Vegas, right? That's the one thing. If aurora happens in Vegas, it better not stay in Vegas or everybody's going to come after you. So Is it possible? Yes, especially dark skies. Get out of the city lights, obviously not on the strip, right? That's not going to help you. But we could. We could very well. Like I said, it got as far south as I am in Los Angeles. You didn't see it in LA because it was too bright, but Joshua Tree, where people actually did see Aurora last November, it actually, that's at the same latitude as me. So we actually could get some decent Aurora clear down into southern Nevada. Absolutely. Okay, better drive south now then. Yeah, you might, Adrian. You're too far north. I don't even know if you have, are you still dealing with too much sunlight? I hope you can see it. This might actually be bright enough to pierce through the sun. If it's like that twilight, right? You might actually be able to see it if you catch it right when the sun is as low as it in the sky as it's going to get. Okay, looks like everybody's getting your twilight here. Lisa, you probably could though. I think in Scotland you're gonna get a decent chance for Aurora. It's all a matter of whether you can have clear skies, right? Is there going to be Aurora in Chicago? Probably not over the city. But if you get out of the city lights, yes, you drive to quiet. And here's the key with Aurora photography: you can use your cell phone. Teach yourself how to take long exposures even with your cell phone, because cell phones are sophisticated enough now to do it. Your cell phone or cameras can see much, much more than the eye. So even if you think there's nothing because you're not seeing anything, don't worry. Take a picture anyway, right? Long exposures, and then take a look at the back of your LCD screen. And there will be a ton of people on Twitter that will help you because there's going to be a lot of field reporters out for this one, I guarantee it. And you'll find somebody in your area and ping them, and they will, because the space weather community on Twitter is more than happy to help you, especially if you're a first-time Aurora photographer or storm chaser. So definitely join the party and get real-time updates right on Twitter. What else was I going to say? Also, if you're an Aurora photographer, just know this: the Aurora is just like the sun and the moon. So it rises in the east and it sets in the west. So as the sun goes down and it becomes nighttime, look for the Aurora on your northeast horizon if you're in the northern hemisphere, southern hemisphere, southeast horizon, right? And then around midnight, it should be as far, up in the sky as it's going to be. And then as the Aurora sets, as it goes to early morning, the Aurora will set in the west. So you'll be looking either northwest or southwest, okay? So just realize that Aurora does rise and set just like the sun and the moon do, okay? All right, let me move on to those for amateur radio operators, emergency responders, drone pilots, Waze users, GPS fanatics, geocachers. Oh my goodness, the list goes on and on, right? Uber drivers. We do have issues right now, right? We have about a 30% chance of M-class flares and at least a 10% chance of X-class flares. That could go up over the next couple days as we're seeing that region 3078, that's the big one right here, is increasing in spot size. And I just realized, I think we have a new region 3083 that's just come online too. So I apologize I didn't get that updated fast enough for you. I'm just keeping it with NOAA right now at 30% and just kind of maybe saying let's hope that it's going to die down as we move further out. Obviously, in about a week, this region will disappear anyway. So expect the noise on the bands to go down only in about a week. Okay. Prior to that, you're probably going to be dealing with some pretty noisy dayside issues, including radio blackouts. Luckily, the solar flux does stay high. We are still in triple digits, and that's not going to change. So this means in between the radio blackouts, you should have good propagation on the day side. However, with solar flux being this high, this means GPS reception, especially at low latitudes near dawn and dusk, gets a little dicey. Add radio blackouts to that, and GPS reception could be very dicey at near dawn and dusk, within a few hours before and after. And then also, of course, once the solar storms hit, GPS is a real problem. Just the reception of it is a real problem anywhere there is Aurora. Okay, so if you're a GPS user, please be very careful. Just be aware that it may not be as reliable as you'd like it to be. And again, it's just the reception. There's nothing wrong with the satellites. It's just the reception has a hard time through the Earth's atmosphere. And then if you are a drone pilot, please be savvy. When the solar storms hit, calibrate your magnetometers often. Otherwise, you're going to get drift and all sorts of other issues that you don't want to have to deal with that make flying very painful. Okay. Again, we talked about radiation storms. We are going to continue the risk for radiation storms. We're a little bit elevated right now because one of the solar storms that was launched earlier gave us just a little bit of rattiness in this. We got a little bit of elevated particles, probably because we're getting shock. There's at least one or more of these solar storms that are coming are driving shock waves. Those shock waves have a tendency to produce elevated levels of particle radiation. So that's going to likely maintain. I'm just saying it over about another day or so. Once the solar storms hit, which will be right around the 18th, things should calm down reasonably quickly. So I've already put us back to a D1 normal range. This may linger. I'm being optimistic that things are going to go down. So really, it's not that big an issue because I don't think it's going to last. But frequent flyers and people who are high-risk passengers, just take a note of this. You're likely fine when it comes to flying, but I just want you to at least be armed with the information you might need. And all of this information here is based at the flight level of 360. So basically 36,000 feet. I'm sorry, it got cut off down here at the bottom, but this is flight level 36,000 feet. I will have these 5-day outlooks in Patreon for you guys here. Actually, I think and a version of this is already up on and a space weather snapshot on social media, so you guys can get access to it. Okay, hopefully that then helps people who need to leave. But for those who would like to know what else is going on, we will continue here. Let me do this. Okay, let me go back to J. Heliovira. Okay, guys. Again, don't worry about it. Nothing is falling. Nothing that this isn't the end of the world. The big issue that we have in terms of well, this is interesting. There we go. The big issue that we have in terms of not understanding, but trying to give an accurate forecast through all of this is, again, as I mentioned before, we've got that coronal hole, right? Now, here's the issue, right? When you have solar storms being launched, we already talked about it kind of cutting off any of the, cutting off even the coronal waves that then can actually cause these structures to be even larger, right? If you have a coronal wave propagating here, a blast wave basically is what we're talking about. It's a blast wave from these eruptions propagating off this way. It helps to tear stuff off of the sun. Well, if you've got this big chasm that is this coronal hole that's kind of stopping that, then the coronal wave doesn't even propagate past, so it doesn't make stuff unstable in this region, which is kind of what we needed to be able to make sure that we had a big solar storm launch. Right. So these solar storms are kind of being truncated and relegated and forced to be kind of down here somewhere. Right. So that makes it a little bit tough. And I'll show you some coronagraphs in a sec. This is why we don't see the full halos on the coronagraphs. But it also, like I mentioned, we got the solar wind that may be also north of these structures as they come out. And that fast solar wind may push these structures and force them to go south of Earth. And those in of themselves, those are just physical mechanisms that may limit how strong these solar storms would be otherwise. The second thing is, if you notice, anytime we have fast solar wind, some of you who know that fast solar wind in of itself can create solar storms, right? Because it's like a boat plowing through a lake, it creates a bow wave. Well, the fast solar wind is kind of like the boat, and it slams into the slow solar wind ahead of it and creates this compression that then can actually hit Earth like a big wave, and that actually causes solar storming. So we do have the additional aspect of that, which is wonderful. But what we typically like is to have a coronal hole that has the right magnetic polarity. So for those of you who are wondering what all these weird spaghetti lines are sitting on top of the sun, it's the magnetic field. And remember, the sun interacts with Earth through its magnetic field, right? So you've got this big magnetic shield that's protecting Earth. I know sci-fi stuff, but big magnetic shield that's protecting Earth. And if you want to simplify it, you can think of it as simply being like a fridge magnet. Okay. And now the sun is going to launch these solar storms at us, which are basically fridge magnets in of themselves. So as you have one fridge magnet coming to another fridge magnet, you put them together. If they're the same polarity, they repel one another. Anyone who's felt the force of these things repelling one another, what you're feeling is the force of these springy magnetic field lines. Okay, you're feeling how springy the magnetic field is. Well, if it's the same polarity, it'll bounce off like a bumper car and move off. But if it's reversed, if one of the polarities is reversed, they click, right? And they become one big magnetic system. And now all of the force from that solar storm can be pushed into and shoved into, literally, the Earth's magnetic system. And the Earth magnetic system goes, oh my goodness, and that's how you get these big geomagnetic storms. Well, not only does that work with solar storms being launched in terms of like what this is, but it also happens when it comes to the magnetic field direction in these big waves, these fast solar wind streams. But in the case of the fast solar wind, we know what the magnetic configuration is going to be. We don't with the solar storms. It's kind of chaotic. There's method to the madness, but it's kind of hard to tell when it just from the pictures of this solar storm launching. But in the coronal holes, it's very much more organized. So we kind of know. Sadly, the magnetic field direction from this coronal hole, you can see these blue lines, these blue tip lines, that is the direction that is going to be less geoeffective. In other words, you're going to have two fridge magnets coming at each other that have the same polarity. So you're going to get a bumper car effect. Now, how much of a difference does that make? I don't know. It's kind of hard to determine that because we have so many solar storms coming too. If it were only this coronal hole and only the solar wind from this coronal hole, I'd go, meh, we make it active conditions. Meh, maybe high latitude stuff. Meh, not a big deal. Plus, this fast wind isn't going to last very long because the coronal hole is super thin. So it's going to be a fast and then stop. Okay. Sadly, though, with the additional solar storms, right, with so many of them coming, I don't really know, other than this fast solar wind coming and creating a wave and compressing everything, I don't really know what's going to happen, how much it's going to enhance it. Will it enhance it? Yes. Will it enhance it as much as the coronal hole we had and the fast solar wind we had just a couple weeks ago? No, not that much. Okay. So it's really going to be up to these solar storms to hit us, is what I'm kind of saying, right? Whether or not they hit us. If they miss us, as you'll see very shortly, there's a chance that they will. If they miss us, well, then this could be a big fizzle. Okay, let's hope not. But I'm just trying to be honest. I know it's not the best way to look at it, but it is the only way. All right. So, you know what I'll do? Let me show you. All right, so let's get to some modeling. Let me do the annotated Enlil. This one. So here is the current model. For those of you who saw NOAA's, and I will post this up on Twitter here shortly. For those of you who saw the model, the Enlil, now this is the Space Weather Prediction Center model. Okay, this is Enlil. This is a solar storm prediction model. For those of you who saw it yesterday, it has changed. Okay, they now have incorporated at least 3, if not 4, of the solar storms that are coming at us. And I'm going to show you this one first because it has all of them on one thing. Then I'll flip over to NASA and show you each one of them that's being modeled individually. All right, so I'll just, hopefully it'll loop. It probably won't loop. Hold on. View loop. Okay. So for those of you who do not know, this is NOAA's version of a very well-known solar storm or coronal mass ejection prediction model, right? And basically what it does is it tells us when will these structures hit Earth. There are a lot of assumptions made in these models. These models are not using as sophisticated of codes as we would like them to use, but if they did, they couldn't run faster than real time. So it wouldn't be a prediction. So we have to simplify the codes quite a bit, which is a problem when it comes to these quote unquote cannibal solar storms, because it makes them look like they eat one another. And that's not what happens. They do not merge. Because they actually have magnetic field that can repel and force them to stay kind of separated, but they can crush one another, which is why I called this forecast the solar storm crush. It's because that's really what's happening. They're not eating one another, they're crushing one another, okay? So bear in mind, you're looking down, in this case, you're looking down at the sun's north pole. Earth here, as you can see, is off to the right. The other 2 spots are stereo A and B. Poor stereo B is still dead, but we still have the predictions for them anyway. And as I'll stop it when it, well, no, I'll wait. I will wait for it to start over. And in this case, the top panel is density, the bottom panel is velocity. So we will concentrate on the top panel because that is really where you can see the solar storms the best. So here is one that was launched. This is the one that was launched on the 14th. Okay, this was the one that was launched by region 3076, I believe. This was the one that was launched in the north. It's mainly going going west of Earth. Okay, and it's very slow. But very shortly thereafter, we had another one launched. You don't know if you can see that yet, but you'll see it as it gets, that's the second one. This one was faster, and you'll watch it. It will merge into this. Crush, not merge, not eat, no cannibal, no. Just crush, okay? So what happens is that they become more compacted, and that's going to up the density quite a bit. That's going to up the impact of these things as they merge. Here it'll look like it becomes a single object. See that? It merged completely. This is because this model has no ability to separate out the magnetic field components and force the magnetic field is just kind of along for the ride. So it's really what we call a hydrodynamic model. Sorry for all the detail, but that's part of the problem. It doesn't become a single storm. They just are think of them as being really close together. Oh, and then here's the next one that was launched. Now this one was launched from region 3078 and is much faster. You will watch it catch up to these very, very quickly. Okay. So as I continue moving around, see how much faster it is? So believe it or not, as I get to here, I'll get right to here. The one from region 3078 was actually reaching Earth before the tail end, what we call the western or the eastern flank of this solar storm. This set of solar storms ends up hitting Earth, but they almost happen together. So this is why you see a double peak on this side. You're actually seeing the region, the solar storm that's Earth directed from region 3078. I can go right to the front of it there. That solar storm, that was from here, reaches us first, okay, even though it was launched last. That will reach us, what they're saying is basically super early on the 18th, okay? And then the second storm is really this tail end of this guy that's launched much further to the west. It's more of a flank hit, but remember, there are multiple solar storms in it. And in actuality, there's maybe even more than that. Now, one thing that I have not talked about as of yet is that most of this, the bulk of these solar storms is actually south of Earth, okay? See, so what we're looking at here, even though this is looking in the ecliptic plane, right, looking down on the sun's north pole, here we're kind of cutting it north-south. The sun's north pole is right here. The sun's south pole will be down over here, okay? And the same thing with Earth. Earth's north pole up here, Earth's south pole here, okay? Here we're looking down at Earth's north pole as well, essentially. Those who are scientists and know that I'm cheating don't get mad. Simplify. So as you can see, the bulk of this structure and these structures, they're all going to go south of us, okay? We're just getting the north tip of it, of all of them, of basically all of them. Not necessarily this one because we're getting the west tip of it. But all the ones that were launched from 3078 are all going mainly south of us. And that's what gives me pause, because we have that fast wind stream, right? We've got that fast solar wind. If that fast solar wind goes and pushes that stuff down and deflects it southward, this could be major fizzle, right? And I mean, we're going to be looking like idiots with oh Lord, yeah, there's those space weather physicists again. They don't know what they're doing. So I want to say, yes, I understand the reasoning why NOAA SWPC has given us a G3 level warning, but that does assume that these solar storms are not going to miss Earth and are not going to be deflected southward. And I cannot tell from the imagery we have right now. I even looked at Stereo's imagery. It is so hard to tell whether or not we have a polar coronal hole in the south that's going to help, push these structures back, back up. So is there competing solar wind, fast solar wind that's coming and blowing this way, just as there's competing solar wind from that fast solar, that coronal hole that's blowing this way. So we have all of this traffic I always call it traffic on the way to Earth that we can't suss out because we have no monitors. The only place we have a monitor is just literally half an hour or an hour in front of Earth, upstream of Earth, right? So the interim is crazy. It's like we have images of you backing out of your driveway in New York City, and now you're going to drive all the way across country, but we have no eyes on you until you get to the LA city limits. How well can you predict how soon someone from New York City is going to reach you if you have no eyes on all the way through the intercontinental traversal, right? That's what space weather is right now, and it's extremely tough for us. So this could be definitely a G3. If these storms hit, it could also be as bad as a fizzle, almost a complete fizzle, if these storms miss. The only one I know I'm really, really sure is going to hit us, or pretty sure is going to hit us, is the one on the 14th, and I'll show you why. So what I'm going to do now is go to seeds. So this is the 14th. Oh, don't do that. I don't want the GIF. I want this. Is this the right one? Is this the 4th? Oh, I need a list. Give me a list. There we go. All right, make this big. So hopefully this will probably won't play over and over again unless I loop it. So here is a chronograph imagery of the big eruption that happened from region 3076. The 3076 was a region that was right in here, that was north, right? And this had, this was the slower eruption. But if you notice when you see it, and I could probably stop it right here, and I'll explain what I mean by difference images in a second. Let me go back to here. If you can see this, so the difference image is basically taking the raw image, the intensity image, and making differencing frames. Each successive frame you subtract from one another. And what that does is that it shows that anything moving from one frame to the next either gets white or dark, depending upon whether it gets brighter or dimmer. And anything that's gray, 50% gray, means that there's no change. So what that does is it highlights features. So something that was reasonably dim to see and hard to see in the intensity image jumps out at you in a difference image. Okay, so in this case, you can actually see this structure, and you can actually see that the halo, this is what we call a halo. A halo is when it's all the way around the sun. You can see this halo, that's a partial halo, but it's really well defined. So this is the one I think will hit us. Now, NASA's modeling showed that this solar storm was not going to hit us, showed it was being too far west of Earth. But NOAA, the modeling I just did show you, just the prediction model I showed you, does show that the western flank of this will hit Earth. And I believe that's true, or rather the eastern flank of this will hit Earth. I believe that is true, this from this halo image. And this one was far enough away from that coronal hole that I don't think it's going to see much traffic from it. It's not going to see much of that fast solar wind. It's launching kind of ahead of it. I think that there's a very good chance that this one will impact us. So luckily, we're going to see some action on the 18th, right? Because that's when this storm hits, and even though it's the slow one, and it's got some other storms behind it. So I do think we're going to see some level of storming. It's really the ones behind it that come out later. So this was on the 14th. Let me show you what happened. Whoops. Let me show you what happened on the 15th. So here's same thing. Here's the chronographs on the 15th. And remember, you're looking for halos, which means something that goes around the sun, you know, to a great degree, right? Either a partial halo or a full halo. You always know that those are going to hit Earth if they're Earth direct or if they're front-sided. Look at this one. See this? Not so, whoops. Loop, of course. Loop, 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 loop. You'll see two of them. I believe you'll see two of them. One and two. Or is that the same one? No, it's the same one. I'm sorry. I didn't show both of them. But here's the big one, the one that I think has a chance of hitting Earth. Notice that, once again, it's kind of compartmented just in this quadrant, right? So it's going to be going south, because this is south, right? North. That's west. I know it looks backwards, but believe it or not, this is west, because you're not looking at a compass rose the same way you'd look at it on an Earth map. West is this direction. I am not confused. This is east, okay? East limb of the sun. So this structure is going to be going mainly southwest of us. This is the one, the biggest one that came out of region, at least on the 15th, that came out of region 3078. Hardly called a partial halo, okay? If that coronal hole pushes this thing south and out of our way, fizzle, right? Because all we'll get is wake, which really frustrates me. So thanks to that coronal hole, it really truncated this thing. This should have been a really nice partial halo, and it really wasn't. And I credit Halo CME for alerting us all to the fact that it even stopped the coronal wave, which means it stopped this structure from really developing fully, which may mean that when we see it at Earth, it's going to be a mess. It may not even have a beautiful three-part structure. Who knows? Or, you know, flux rope structure. Okay, so that's one. This is a faster structure, by the way, right? So this is one of the ones that's going to catch up and actually, that caught up to the slower structure that was launched on the 14th. And then finally, I'll show you the one that was launched today, before the most recent solar flare. So we may have had two launched today, and I'm sorry I don't have this one annotated yet. But once again, partial halo. Oh, shoot. Okay, come on. Partial halo? Hard to say, right? Doesn't quite look like a partial halo. It's just, it's like it's been stymied. It should have been a better structure. It was launched quickly. So once again, this is another structure that's moving quite quickly. This is the one I believe on, yes, that NOAA has included in their model. This is the one that's going to hit Earth, and again, right on the 18th, early morning, okay, followed by the others. So we hope that this one isn't going to be pushed south of us, but it also could be pushed south. If so, once again, now we're dealing with potentially a total fizzle. So let's hope not. And I think that's all I want to show you there. Let me go back now. What do I want to show you? Oh, I lost my train of thought. Oh, right. Annotated NASA movies. Okay. So let me show you. I'll show you quickly here. So here is NOAA's or NASA's version of the model. So this is now going to show you those same three CMEs essentially, with NASA's version of Enlil. Okay. And again, I'll probably have to loop it. And then as soon as I show you those three, I will then pause for questions, just in case any of you are itching to ask me questions. So here's oh, this isn't the right one. Where's the one? Did I do the one on the west? I hope so. Hold on a sec, guys. Oh, did I mislabel this one? It's always a comedy, always a comedy. There it is. Okay. I do not know why I had labeled that one 15th. All right, here's the first one I wanted to show. Here's the one that was launched on the 14th that's going west of us. Okay, so again, this is because this is NASA's version of Enlil, you're looking at a slightly different version. We're only looking at the density panel. This is just easier for me to grab than having to paste things together. They always publish their density and their velocities in different images. So I just grabbed the density one since that's the one that makes all the pretty, you know, bubbles that you can see. Looking down at the sun from the North Pole, okay, the pinwheel arms, by the way, in case you're interested, those are the fast wind streams, all right? And I should say the colored pinwheel arms. Those are the fast wind streams. And you can see this solar storm, that was the one that was launched from region 3076, I believe it was, moving off to the west of Earth. In the NOAA model, I mean the NASA model, this model, notice that you don't really get an impact. In fact, when you go to the splash screen, this is what we call where you get like a puddle, a splash through basically the field of view, the plane of the sky that includes Earth. You can see north is now pointing this way, south is that way, west this way, east this way. So it's through the north-south cut of Earth, but you see what we call the impact footprint. You can see it's basically going to be southwest of Earth. So that's going to be where the impact of the structure is. According to NASA, this structure won't even hit Earth. NOAA says yes, it will, just to the just the hairy edge of it. So from the coronagraphs, this is the one that gave us a bit of a halo. I think this structure will hit Earth. Okay, I think NOAA has a better read on this one than does NASA. That's not always true, but in this case, yes. Now, if there is an impact, according to NASA, as I look at, whoop, be somewhere around here, noon on the 18th. NOAA said about 2 in the morning on the 18th. So already between the two agencies, we have a bit of a discrepancy. No, they're not fighting one another. They're just multiple scientists in the loop. We're all trying to figure this out. This is the best we can do. Remember, we've got a solar storm, and all we have is how fast is it backing out of its driveway in New York City, right? And we're trying to predict when it's going to arrive in LA. So this is actually a pretty good prediction, having them not being that far away from one another. Not too bad, okay? But the question is intensity. How impactful is it going to be at Earth? Is the flank going to hit? Is the edge going to hit Earth or not? Okay. So that's one of the biggest issues there. Okay. So that's that one. Then, so remember that noon on the 18th. This is why 18th is such an important day. Let me do this one now. Right. So this was one of the next ones that was launched from. Now this is from region 3078. Got to keep them all straight. See why I had to do a live briefing, guys? It's too many of them. Oh, shoot. I'm going to have to put this on loop again. So here is what looks like a teeny tiny little guy. Well, it's not teeny tiny, to be totally honest. It's just mainly going south of us. And look how, we're only catching the northern tip of it. And that's why it looks like it's so teeny tiny coming through the ecliptic plane, right, hitting Earth. And again, if we look at the splash for this one, again, almost drew south. See why I'm getting concerned about having that coronal hole with a fast solar wind potentially pushing and deflecting these things further south? We're already on the hairy edge of having it miss us. Okay, so this is not favorable. However, be that as it may, if I look at the impact time, they're saying it here. Well, it's probably a little. Let me go a little bit further. Yeah, there. Late on the 17th, okay, 1800 on the 17th, so almost the 18th, right? Chances of it being slower, arriving slower than expected, yeah, probably. So again, 18th looks like a big deal, right? So we've had now 2 solar storms that are impacting almost, sometime on the 18th, maybe just prior to or about midday, right? And even NOAA is saying the 18th is when these things are going to hit. Let's take a look at another one. So here's one of the ones that was very fast, launched on the same day, on the 15th, from region 3078. Let me loop this one too. Man, I need to set that as a default. Okay. So here's a faster one. Okay, trust me, these are different storms, even though it looks up. But remember, region 3078 it's machine gunning these solar storms. So the source region is not only staying the same, it's almost in the same position. So of course you're going to see solar storm launches that look almost identical, which really makes it difficult for us to keep them separated. But this is yet another solar storm being launched, a bit more intense, a bit faster. This is the one that's expected to hit Earth quickly. This was the big one that I showed you in the coronagraphs. I didn't bother showing you the other one. There've been like 6 of them. But this is the bigger of the two. This is the one that I think that if it's going to be a decent impact on the 15th, from one of the 15th launches, August 15th launches, this is going to be the one. Even the impact footprint looks far better, right? You actually have something that is, according to NASA, still is not the greatest, right? I'm showing bing, 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 bing. Okay, back and forth, back and forth. Okay, go ahead and I'll go ahead and put that there so you can see how, it's an intense impact that does reach Earth, but just hitting the base of it, right? So you can see it. It's going to hit. Now when? 18th. So there's 3 storms, right? Now we have 3 still hitting on the same day. Oh my goodness. Can you see how this is a solar storm crush? Right. So that's what we got. We got a solar storm crush, guys. And now we have another. This was the storm that was launched today prior to the solar flare that hit basically while was just getting online with you. So this does not include that solar storm. We may have yet another solar storm coming, but this is the one that hit earlier today. Whoops, I probably have to. Now, this one has not, I'm not sure. No, this is the one that NOAA did include in their thing. This is the one that's going to hit probably first, I believe, if I'm keeping my solar storm straight. I am a little bit surprised that in this model that we had a solar storm with that big a footprint in the ecliptic plane, because again, the bulk of the structure is moving south of us. See this? But we have but it's an intense storm. And so even though the bulk of it is moving south of us, it still has a really strong footprint that's looks like a direct hit at Earth. Don't be fooled, okay? It's not a direct hit. You can see again, the bulk of it is moving south of us. But there is a good section of that northern part of that solar storm. If I do this, you can see how much of that solar storm is actually, boom, right there, that wave of stuff that goes over my hand. See that? Whoosh. So that is a really good encapsulation of Earth. And you can see even in the impact footprint, if I stop it at the right time, or back it up rather. Yeah. There you go. Yeah. See that? So we do have a much better chance of getting hit by this structure, even if that solar wind pushes it south. All right. But nonetheless, and then this one is going to be on the 19th. Okay. So this is the latest of the grouping. So this is why I'm saying storming is going to extend. But we could have a situation where we're going to have, at least 3 solar storms hitting on the 18th and then lingering into the 19th, and this one might do it. And now we may have one more. So could that 5-day outlook that I put up before, could it change even more? Oh my goodness, yes. Right? So the takeaway, I guess, in this sense is, could all of this shift even further, right? So now take your minor storm and just double it and have this continue to push out. Yes, we could. Okay. But this is why NOAA is giving us such a large chance for a G3 and a 90% chance of a G3 at high latitudes and a 50% chance down here. Well, that pushes us into thinking, yeah, we're going to hit it. My caveat is that one or more of these solar storms that are in this crush could miss us entirely, right? Could be pushed southward of us and thereby potentially weakening the impact, right? So we may have like a real big uptick and then things kind of die down, and a real big uptick and then things die down, depending upon how many of these solar storm crushes, in this big crush end up actually crushing on Earth. This should be Valentine's Day. We have too many crushes, right? How many Valentine's Day crushes can you have? So this is a crush that's not happening on Valentine's Day, but nonetheless, it's a very exciting time. Don't worry. As soon as we get G3 warnings and alerts, national grids are put on alert. They have mitigating procedures that they put in place for power grids, anything over a G2. So they're already being alerted. Don't worry about it. I chatted with one of my ex-students just today. They're already putting out the alert to not just to the FAA, but even their own private airlines. There are airline companies that contract with different agencies to get space weather alerts now. It's becoming a bigger deal. So thank goodness. And a lot of that is due to all of you being so aware and raising the awareness of space weather. So, I bow to you all. And yes, I'm already seeing the word going out. So don't worry about it. The chances of this going any higher than a G3, I really don't think so. If anything, like I said, I think this forecast is optimistic and things will probably, there's a good chance it'll stay down at a G2 level. It could even be a fizzle, my goodness, and just stay at active or even minor storm conditions, meaning a G1. That is possible. And know that even if this bad actor continues to and fire off these big storms, they're all south and they're all being truncated by this coronal hole. It's kind of self-limiting. So I don't think we're going to see any solar storms that are any worse or different. And they all could easily miss Earth going south of us. Okay, so these if you're going to get super excited in a scary way, these are not the storms to do that with. Okay. But this is a great time to go out and see aurora because there's probably going to be some decent ones. And if you're a radio amateur or a satellite operator, oh, just get ready. You know, we're going to be dealing with spacecraft charging, dealing with noise on the bands, communication issues, that type of thing. If you're looking at the Artemis launch, it may be delayed. I don't know, especially now that we have an X-Flare player. So the chances of radiation storms, the chances of radio comms issues during launch, and then launching during a solar storm when other things can go out, not necessarily something they want to do. So don't be surprised if that launch gets delayed until after these storms calm down. Okay, so just be aware of that. All right, and that's really all I wanted to present. I'm going to check Patreon to see if anybody's got me on a feed there, and then I'll start answering questions here on YouTube. So if you are a Patreon person and you want to ping me directly, feel free. Okay, let's see. Oh, Mike, so sorry, past my bedtime. Okay. Good, Vince. I'm glad you're watching live. Yes, Lisa. Hello, Paul. I hope you're watching. Wonderful. Hi from Andover and Andover. Lex, okay. Do you think we will definitely, this is Lex saying, do you think we will definitely land up in a G3? Okay, yeah. Or do you think a G2 is more probable? Lex, you were the whole reason why I decided that absolutely I was going to do a forecast and talk specifically about this. Julian says, does a flareless CME have a more directional propagation than regular ones? No. Yeah, well, we're getting filament, excuse me, filament eruptions, and those have, that's what typically happens. Hold on, let me just check the rest of the questions. I understand that solar winds are primarily protons. And wind noise that we hear on HF. Okay, how much do the flares contribute to the solar wind? Nothing. What can M or X flares consistently do with operating conditions? Okay, yes. So regarding filaments, so Julian, I'll answer your question really quickly. Regarding filaments, the filament eruptions, yes, these can be flareless because they don't have to happen near an active region. They also can lift off very gently. Stealth CMEs are a classic example of these very quiescent, high altitude, filamentary structures or filament channels that fill and lift off very passively with very little, if no, signature in the X-ray flux. So they can be flareless. CMEs do not have to be associated with solar flares, and solar flares do not have to be associated with CMEs. They are two totally separate phenomena and should not be conflated. The fact that people oftentimes link them together or think that they're the same thing because they happen simultaneously very often. Not always, but often. So that becomes a real problem for us. But they don't have to happen together. Now, regarding, and no, they're not more directional because, again, it's all about the traffic from from Earth or from the sun to Earth. If there's a lot of traffic in the way, if there's solar winds that are moving, if there's different density things, if there's stuff in front, slow wind, fast wind, that type of thing, it can really deflect and change the direction of these structures. Plus, some of them, how they are launched, they can absolutely cartwheel and do all sorts of bizarre things. In fact, there are arguments that a flareless coronal mass ejection will be less directional because it's more buffeted around. The stronger eruptions that move more quickly, they're bullies. They're the bullies of the inner heliosphere. They'll just bully anything and push it out of the way. Where the other ones are kind of fluffy and gentle, and they have a tendency to get buffeted around more. So really, it's the extreme events that I think are far easier and far more directional and far easier to forecast than the other ones. Okay, so regarding solar wind is actually also plasma of everything. Believe it or not, even you can get basically every element under the sun, so to speak. And radiation storms are the same thing. You can actually get gold. If anybody worries about radiation storms, just realize that we actually do find gold in radiation storms. So the sun is actually raining gold on us. Not very much, but there is a little bit. And so, you can actually get every element. In the solar wind, the average solar wind, we do get protons and electrons mainly, but there are other ions associated. And there aren't more of one, of more positive charge than negative charge. That you actually get, it's quasi-neutral. So you get as many protons as electrons, that type of thing. There's never a single charged state that arrives. We just talk much more about the protons than the electrons, mainly, well, for a lot of reasons. But when we measure the plasma, we're measuring the proton temperatures and the proton velocities. The electrons are there too. We just have a tendency to bias our measurements that way for, like I said, a lot of different reasons. Electric fields can get in the way, and electrons are so tiny. It's much easier to measure protons because of their inertia. At least that's my understanding. I know that there are maybe scientists out there who would argue with that. At any rate, it's not necessarily that the solar wind affects HF radio directly. The noise on the bands is more from radio noise. When you get a solar flare, there's multiple things that happen. One is the ionosphere lights up because of X-ray and EUV flux. That can cause radio blackouts in the HF range. But then you can also get radio bursts, which is what I call the sun screaming. That's actually when you get these chirps, literally, or screams from the sun that can go up to gigahertz range. You can get them in the microwave range and even higher. And so that can actually black out, the even satellite communications. Not that it's taking the communications out. It's not. It's just masking it, right? Because the sun is screaming louder than the satellites can communicate. So it's kind of like what I've always called the cricket in the train tracks, right? The satellites are the cricket and they chirp all along, but if they're near a train track, you can hear that cricket as long as a train isn't going by. The train is the sun screaming during a solar flare. And when you get the high radio bursts, then if the train's screaming at at the L band range, well, then you're not going to receive the GPS signals because you can't hear the cricket chirping in the L range, right? The L bands are gone. So it doesn't injure the satellite, just like the train isn't killing the cricket. You just have to wait for the train to go by and everything to get quiet again for you to be able to hear the cricket. And that's really how radio blackouts affect, at least in the higher frequencies. For the HF range, it has a lot to do with how the ionosphere is lit up. And I've talked a lot about this in my mini courses, so we can chat more about that later on. So hopefully that answers that question. But all of that only happens on the day side of Earth. That's the nice thing, is when it comes to solar flares, solar flares only affect the day side of Earth. If you can see the region that is flaring, right, you can see that region. You can hear the sun scream. If you're on the night side of Earth, you're protected. But that's not the case with solar storms, the ones that cause aurora. Those impacts are felt mainly on the Earth's night side, and then the effects can propagate to the day side. Even in amateur radio, it happens mainly on the night side, and then slowly over the next few days, then you start feeling those storm effects on the day side. But that's the difference between solar flares and coronal mass ejections, or solar storms. Solar flares affect the day side mainly, solar storms affect the night side mainly, which makes it really hard to conflate the two, at least when it comes to their effects at Earth. But it makes it very confusing as well. So hopefully I answered those questions, guys. What about everybody on YouTube? Did I hopefully answer everyone's questions? You guys get sick of me? I will go back, I promise, to look at all the stuff that you've asked. But if you have a burning question that I have not yet answered, please feel free to post it. I'll stay on for a few more minutes. Oh, good. Okay. Yeah, I see people answering each other's questions. This is good. All great. Wonderful. I'm so glad you guys are happy. Questions answered. Wonderful. Appreciate that. What is a projector quart? Okay, I see someone who's asked. Scooter Dog says, we love you, Tab. Well, thank you so much. Oh, Matthew Shipley, good to see you. Does the fact that many of these CMEs cover the coronal hole north of the region before dispersing increase the chance of it being Earth directed? Does many of these cover the whole? Yeah, I don't know. It's hard to tell whether or not that region, as it's beginning to kind of bridge that chasm of that coronal hole, whether that's actually stopping that fast solar wind or not. I can't answer that. It's a good observation, but it's really difficult to answer. And again, is it a transient thing, or is that coronal hole reforming underneath it? That's hard to say. So I don't want to discount the fact that that coronal hole is there, right? But it does make forecasting more difficult because I don't know. Does it stop that fast solar wind during the period of that and prevent it from launching any more fast solar wind because it looks like it's closing? Hard to tell because all we get to see is an integrated image, right? We don't know what's going on underneath all of that stuff, right? What's going on at lower altitudes? Is that coronal hole still there and it's just being covered by an umbrella? Don't know. It's not something we can easily answer. Okay, I think I missed one question, but I see another. Julian, okay, good. I'm glad you got your question answered. Okay, any other questions, guys? Thanks, Jerry, for repeating Matt's question. I appreciate that. And Matt, you and I can chat later on as well on Patreon if you'd like. That works for me. Good. Something to wait and see. Yeah. I mean, this is what makes it so difficult, right? Because if we had direct hits, it'd be so much easier to say, well, that the coronal hole, the influence of that coronal hole is not going to push this structure out of the way because it'd have to really push it a lot. In this case, it's already almost missing Earth. So how much does it have to push it and deflect that structure? Not very much. So that's the big concern. So if we end up having fizzles, now you know why. At least you'll be able to understand and hopefully not, pelt too many space physicists with olives or the Space Weather Prediction Center. They're doing the best they can. Okay. Any other questions, guys? Because I think I've stayed on here quite a long time for you. I hope I've answered everything you needed to know and then some. But if that's, okay, I see one question. Exiting the coronal hole, this is from Secret Owl. Exiting the coronal hole stream may cause any snapping back towards Earth like a rubber band. No, not at all. No, because the solar wind is always pushing back. Are you talking about the Earth's magnetic system snapping back like a rubber band? If that's the case, yes, that's the slingshot. Yes, that's going to happen all during these solar storms. So it's not even just the solar wind. As the solar storms wane, though, I don't think we're going to get a huge reverse shock pulse. Mainly because we have one more solar storm coming and maybe another one after that. And so we're going to continue to get these, we're going to get one on the 19th. We're going to get another one possibly after that, which was the one that we had that solar flare, goodness. Oh no. Look, we have something else. Okay. So now we've got another one coming. Okay. So see, this region's not done. I bet you this is once again region 3078. And so this, whatever happened here, we don't have that solar storm. If there is a solar storm coming from this region, this is not factored into this forecast. As you can see, the region is still continuing to be active. We may have yet more solar storms hitting, being launched as we speak. It's just a moving target, So let me just see if anyone else is talking to me. No wonder the 27-day, this is Chuck, I'm trying to read. No wonder the 27-day forecast is so wrong so often. Exactly. Thanks, Chuck. Very tough to forecast that many days out when things are changing in real time. 27-day forecasts are wonderful during the descending phase of the solar cycle and through solar minimum. Outside of that, forget it, right? As we move to the ascending phase and the sun wakes up, everything changes so dramatically. You just can't trust it, okay? Melinda, thank you. Aloha from Hawaii. Wish Aurora action would hit us here. Yeah, let's hope not. I don't want Aurora hitting Hawaii because that would mean probably a G5, and I really don't want to see a G5. Yeah, I mean I love Hawaii, but no, no Aurora in Hawaii. Let's not do that. That would make me very busy. I would be a very busy woman at that time. But that was cute. Thank you. Okay, what modulates the variation on SFI? Yes, sun's rotation. You got it. I didn't see who sent me that question, but yes, it is exactly the sun's rotation. Right now, we are seeing one side of the sun, one hemisphere, mainly the northern hemisphere. For some reason, the northern hemisphere is only lighting up on one side of the sun. The southern hemisphere had done that about 6 months ago. So the northern hemisphere is now following suit, and because of that, we're getting every 14 days, essentially, it goes from being very bright to very dark. It's with the dark side of the sun. You never thought you'd hear that, would you? But there actually is a dark side of the sun, at least right now. And obviously that's a relative term, right? There's never a dark side of the sun, but there is a darker side of the sun. And so, yes, it's mainly the northern hemisphere with its lack of sunspots on one side of the sun relative to the other right now. And so expect that to continue. You watch the SFI, the solar flux, kind of jump up and down and up and down. I don't know. Even Scott McIntosh is saying, this is quite interesting. We're seeing it in the north and not in the south. The south seems to be much higher frequency, but the north is, doing these slower things. So we're still learning. We're learning about how the sun works, and it's very intriguing. But yes, we're expecting to probably see that easily for another, I would say, 3 to 6 months before it smooths out. I do believe it will smooth out, though, because I do believe the northern hemisphere will get its act together. Okay. Can you shift to your right, please? I'm trying to read what's behind you. Oh, I'm sorry. I'll stand out of the way. There you go, Julie. Yeah, I hope you can read it. You probably can't. What this is X-ray flux. This is from August 14th all the way to today. So it's only 3 days. And you can tell we're sitting, this is the seafloor, what I call the seafloor, if you can see that very gray line. This is what I call the seafloor. This is when we have a background X-ray flux around the seafloor, that means we're definitely flare active and you're getting noise on the bands, on the amateur radio bands. This is not the solar flux, though. This is X-ray flux, which is slightly different, but it's a decent proxy for solar flux, at least for solar flux activity. And you can see the X-ray flares coming up. This is the M flare threat level. So anything that pops over that, and almost all of this, as you can see it ramping up and getting higher, even the high, this is the more energetic X-ray flux, what we call the short wave. 1 to 4 angstroms, I believe. And then this is slightly lower energy, so we got more flux of it. But you can see the shortwave ended up ramping up quite a bit. And we're getting M flares. So you can see we've actually had quite a few. This was almost an M. There's an M. Just below, there's another M. Here's an M5 that we had just recently, and now we just had another M, almost M2. So these are all from region 3078. And this is why amateur radio operators are hating life right now. So Joe says, thank you for the stellar news updates. You're very welcome. Stellar, cute, very cute. So hopefully that gives you an idea of what this is, and I got out of the way. Sorry, you probably can't read this, but that just tells you that's just a marker. If you go to the Space Weather Predictions page, you can see this. You can look at it more closely yourself. Okay. Thanks, Frank. That's very cute. I appreciate that. Raining in Rhode Island yet? Oh my gosh, yeah. Definitely check your local weather forecast. But this nice is that you're going to have potentially, 2 to 3 days of multiple solar storm hits. And remember, once the Earth's system is rattled by one solar storm, it makes it that much easier for it to, to get rattled again. So that's one nice thing, and that's another reason why SWPC is talking about a G3 level, is that we're getting hit not only by so many solar storms, but you're preconditioning the Earth to storm. And so that's what makes you ratchet it up kind of the impact every single time a new storm hits. Infodog, we appreciate all you do. Oh, excellent. I'm so glad you guys enjoyed it. Okay. Yeah, I'm not available right now to discuss sunspots. You might be able to put it as a comment sometime, but I'm going to have to get going here. Let's see. Any other questions, especially from Patreon people? Thanks, Daniel. I appreciate it. How do we ensure clear skies? Yeah, I know. I wish. Blow. I have no idea. I wish I knew how to do that, to get the clear skies for you. Okay, guys. Great, Matthew. Time to keep an eye on the sky at night for the aurora. That's right. That's right, guys. Oh, Tyler, wonderful. You mentioned Perth, even better news. Yes, you might. So, Tyler, if you're in Perth, yeah, get to dark skies and take a look and just pay attention. Definitely look south, and remember, if it's early in the evening, look southeast. If it ends up being early in the morning, you look southwest, because the aurora does rise and set just like the sun and the moon. You're welcome, Jerry. Thank you again for being such a great moderator. I appreciate it, and elevating people's questions when I didn't get a chance to see them. And thanks, guys. Enjoy, right? And there may be more to come. So even as we go through these next few days, pay attention, because the sun is still launching solar storms. So we may have a few more solar storms on top of this, all right? So this might be a very, very fun week for us. And rest easy. All the big agencies know what to do. And this is not, nothing like a Carrington events. So just sit back, enjoy, and have fun. Okay. Watch on Twitter. If you're not anywhere you can actually see Aurora, just watch on Twitter. Okay, guys.